Here I am presenting about different materials and its properties. So why should we study about engineering materials and their properties? We should know the properties of materials so that we can use it as per our need of the job what we are doing, and the knowledge of varieties of materials gives us an idea when we have already prepared something and made something a design, whether it suits our design or our need or not. Now, coming to the classification of engineering materials. Engineering materials are classified into two types. One is metals and one is non-metals. And metals such as iron, steel, copper, and non-metals examples like rubber, plastic, and so on. Now, metals is further classified into two types. That is one ferrous metal and non-ferrous metal. So, what is ferrous metal? Ferrous metals are those metals whose have their main component as iron, and non-ferrous metals are those metals which have their main component other than iron. Some examples of ferrous metals are carbon steel, cast iron, wrought iron, etc. And non-ferrous metals, some non-ferrous metals are aluminum, tin, and so on. Now, selection of materials. Proper selection of materials is very essential. We should always keep few things in mind, and they are the material should be satisfy the material should satisfy all our basic needs as well as our demands for the purpose we are using, and it should be of a minimum cost, and we should always check the availability of materials, and the material should be reliable. Like for example, in the countryside, bridges are often made of wood, we have seen, that is over a small pool or small streams, whereas in the cities or places where we always see busy traffic, at their bridges are generally made up of metal or concrete, because the iron is more reliable than wood as per its higher strength, because iron is higher strength than wood. That's why it is so. And we should always have the material that is ease of joining. So what do you mean by ease of joining? I am explaining with an example. When we are joining two metals by welding, then the welded properties of both the metals should be kind of a similar. It should not happen that one metal melts in welding temperature and other remains the same without even a bit of softness. Then it will not fulfill our purpose. Now coming to the ease of application. What do you mean by ease of application? The materials which we are choosing for our need and for our purpose, it must be ease of application means easily machined, or we can cut, weld, or effortlessly assemble the product. That is all about ease of fabrication always. And we should also check the mechanical properties like strength, hardness, stiffness, and so on, and electrical properties like conductivity, resistivity, and etc. Now coming to the next slide, physical properties of metals. Physical properties of metals are generally shiny and lustrous, with some exception such as lead, and different metals have differ in their colors. For example, gold having its own color, that is yellowish, and copper having its own color, that is pink to brownish in color. Metal differ in shape, size, as well as density. Metals have different metals have different thermal conductivity. So what do you mean by thermal conductivity? Thermal conductivity is the measure of the availability of materials to conduct the heat. For example, if we keep a pan in a oven, the it becomes after some time, we if we check the pan, it becomes completely hot even after the fire is only at the bottom. This results on because of thermal conductivity. And metals have sharp melting and boiling point. Now coming to some mechanical properties of metals. Mechanical properties which are associated with the availability of material under the action of mechanical properties. Uh, there are several mechanical properties such as strength, stiffness, elasticity, plasticity. We will discuss in the next slides. Now, strength. So what is strength? When we apply some force or load on a body, that causes deformation due to that force, and now the body tries to resist the deformation. That internal strength, the internal resistance which the body provides to in result of that force is known as stress, and the ability of the material to resist the external force which we are providing from outside, that is without breaking or deformation of that body, is known as strength. Now what is stiffness? Stiffness is the extent to which an object resists its deformation in response to the force which is applied from outside. It is a complementary concept to flexibility kind of. The more flexible the object, the less stiff an object is. Now, what do you mean by elasticity? When we apply force on a body, the body undergoes deformation, and the property due to which the body regains its shape to its original is known as its elasticity. This is because of elasticity. And plasticity is the complementary of elasticity. Even after the load is removed from the body does not come back to its original shape, and it gets a completely permanent deformation. This two are completely opposite term or complementary term. Now coming to ductility. Ductility is the ability of material to drawn into wires, into thin wires or into wires. For example, if we take aluminum rod and stress it and keep on applying stress even after its elastic limit, then it will keep on plastically deforming and increasing in length. It results in increasing in length as well as reduce in area until it ultimately necks and breaks. Before that, it will completely stretch and it will elongate. Now the example of ductility is aluminum only. And coming to brittleness, brittleness is the property that is opposite to ductility. In case of ductile material, the material stresses to large extent with some plastic deformation, whereas in case of brittle material, it breaks with little permanent distortion. For example, cast iron, we can say. Now coming to malleability, it is the property of metals which allows to be rolled and written into thin sheets. We are day by daily use some materials which is very malleable, that is aluminum foil. In our day to day life, everyone uses it. Now coming to toughness, it is the property of material to absorb energy until it fracture completely due to high impact loads. And what do you mean by impact loads? Impact loads means a load given to the material regularly, means once I have put the load and I have again withdrawn it and again I have done so. This is called toughness. This reduce the strength of that material. Machinability. Machinability is the property of a material which states how easily a metal can be cut or machined. A good malleability indicates a good surface finish, that is, it should be of equal in every places. The surface should not be rough and improper and low force. A good malleability also indicates low force and power requirement too, with a long life too. Resilience. It is the ability of a material to absorb energy when it is elastically deformed. And we can take an example of resilience, that is spring. Now coming to fatigue. The fatigue is the weakening of a material due to cyclic loading or repeated loading which we are providing from outside, and that results in progressive damage as well as growth of cracks in the structure. Fatigue results in failures before the yield point of that material. Now coming to hardness. Hardness is the resistance of a material to local plastic deformation due to indentation or penetration. Now ferrous metals. So I have already said that what is ferrous metals. Ferrous metals are those metals which are their main components as iron. Is called ferrous metal. The raw material of ferrous metal is pig iron, which we get by smelting iron ore with coke and limestone. Pig iron was worked into wrought iron in finery forges, later puddling furnaces, and more recently into steel. So, what do you mean by finery forges? When we heat something and give it a shape, That is called finery forges. And puddling furnaces is conversion of pig iron to wrought iron, subjected to heat and frequent stirring in a furnace in the presence of oxidizing substances. This is known as puddling furnaces. Now, some ferrous metals are cast iron. Cast iron is where cast iron is used. Cast iron is used in making parts such as cylinder, head, and pipe. It is formed by remelting pig iron with coke and limestone in the furnace. It is kind of a brittle substance and resistant to wear and tear. Wrought iron. Wrought iron is used in alligators, that is in making fences, gates, and so on. It is a alloy where it contains a little amount of carbon and mostly pure iron it contains. So coming to steel. Steel is used in many places like infrastructure, ships, weapons as well. Steel is made by adding carbon to iron, where it hardens the iron. Steel is a steel has many very hardness. It is so we generally use steel in many places. Steel is carbon and alloy steel is a different steels only. It is a variety of steels. It contains carbon steel contains more carbon in comparison to any other steels, which makes it hard and stronger. And alloy steel imparts greater strength, durability with increasing its weight. Stainless steel is a alloy steel.
Shreya, you are not audible.
Yes, sir. Sorry, sir. So, and now coming to aluminium, copper, gunmetal, and lead. These are examples of some ferrous metals. Aluminium, it is a lightweight white metal, and we produce or obtain it from bauxite. We obtain it from bauxite. It is a widely used in industries, and we day generally used in aluminium foils. It is which we get from aluminium. Now, copper. Copper is a soft, malleable, and ductile material. For example, copper wires are widely used nowadays. Gunmetal. It is a strong and resist to corrosion, and previously it is used in making guns as well as weapons. Lead. Lead is a very soft metal and can be cut with a knife. It has no tenacity. That is, it cannot be gripped properly. It is a kind of slippery. Tenacity means there is a slipness kind of thing. Now coming to some non-metallic materials. Non-metallic materials are those which lack in all their metallic attributes. They are good insulators of heat and electricity. Mostly they are found in gaseous form and sometimes liquid. And some are also even at room temperature like carbon, sulfur and phosphorus. Some examples of non-metallic materials are plastic, rubber. Now plastics, it is a polymer. These are synthetic materials that can take up any shape on the application of pressure in the presence or absence of heat too. Rubber. Rubber is a resin kind of. It acts as a good insulator, and soft rubber is also used in insulation nowadays. Resin is a natural or synthetic organic compound which we of non-crystalline or viscous liquid substances. Resin is kind of. Now, why we should study engineering materials? When we develop a new material, it has a long history or a timeline to it, from planning to investigation or from problem to its solution. Learning about various materials and their way is impact our lives in the essence of material science. Even in the presentation, the few points what I have put forward are the essence of all the development which we see recent days. As the challenge in the course of development is becoming more and more complex, thus the requirement of material science is also approaching well. Thank you, sir. That's all about my presentation.